Hello everyone, welcome back to another banger video. Today, we're going to be building a Python tool that can encrypt and decrypt files using the Advanced Encryption Standard, also known as AES. So yep, let's hop right into it. Cryptography is a technique used to protect data and communications from adversaries by making them unreadable unless you have a specific key. It's fundamental in securing systems and data in a wide range of computing applications, including web browsing, email, cloud storage, and more. For this project, we're going to need a Python library called PyCryptodome. PyCryptodome provides us with a robust collection of cryptographic operations, including the AES algorithm we're going to use. To install it, we first have to go to the shell and type in pip install PyCryptodome, but since we're in Replit, we just have to import our libraries and it will automatically install, so we're going to do that now. All right, let's run this, make sure it works. So the crypto.cipher module provides the AES class, which we'll use to create our cipher objects. Crypto.util.padding contains the functions pad and unpad, which allow us to add and remove padding from our data, as AES requires inputs to be a multiple of 16 bytes. Crypto.random provides a function to generate secure random bytes. Alright, now let's go ahead and define our encryption function. Right, let's run this, make sure it works. Looks good. So in our encrypt file function, we first create a new AES cipher object with our key and set it to use the cipher block chaining, or CBC mode. CBC is a method to encrypt data in blocks instead of all at once, and each block of plaintext is XOR'd with the previous ciphertext blocks before being encrypted. This helps us achieve a higher level of security. Then, we open the file we want to encrypt in binary read mode. We read its contents to a variable named plaintext. We encrypt the plaintext after padding it to ensure its size is a multiple of AES's block size, which was 16 bytes, and the ciphertext is the encrypted result. The IV, or initialization vector, is a random value that is used as the first block to start the encryption process in CBC mode. It's not secret, but it should be random and unique every time that we perform the encryption. Finally, we return the concatenation of the IV and the ciphertext. This is because the same IV will be necessary to decrypt the ciphertext later. Now we can go ahead and write out our decryption function. Alright, we're going to go ahead and run this and make sure that everything is good. Alright, looks good. So the decrypt file function, takes the file name, the key, and the IV prepended ciphertext as inputs. We first extract the IV and the ciphertext from the IV and ciphertext variable. We then create a new AES cipher object, similar to what we did in the encryption function, but this time we also provide the IV. We then decrypt the ciphertext and unpad it to get our original plaintext. Finally, we rewrite or we write the plaintext into the specified file. All right, and lastly, we're going to add some user interaction to our script. Sure, this is indented. Here, we generate a 16-byte key using the getRandomBytes function. Then we ask the user if they want to encrypt or decrypt the file and to provide the file name. Based on the user's choice, we either call our encrypt file or decrypt file function. For encryption, we write the result to a file named encrypted file, and for decryption, we read the encrypted content from encrypted file and write the decrypted content to decrypted file. Let's go ahead and make sure we don't have any errors. Oh, forgot to double equals anymore. All right, looks good. So that's going to be it for this video. If you found it helpful, drop a like on the video and we'll catch you in the next one.